recording.
Hey guys, hope you guys have had a good Monday. Hopefully it wasn't too cold. I know personally I was freezing, but hopefully this lecture will warm you guys up. To get started, let's start with a bit of logistics. In terms of announcements, we pushed A1 the due date for A1 past till Wednesday. So you have an extra day to do it because we realized that we opened the CMS assignment late. So we just opened it for an extra day just so we can kind of compensate for that. However, partner matching forms are due tonight. So if you're interested in working with someone, or if you want to be, even if you have someone you know you want to work with, or if you don't know anyone in this class and you'd like to be paired up with someone, you have to fill out the form regardless. This is just so that when Richie is creating the GitHub repositories for A2, he'll be able to basically make your repos together. Does that make sense? So you can find those links on Ed, but I'll also release another announcement tonight to kind of clarify that. Mentorship forms are due Thursday. Just to reiterate, this is not mandatory, so you can choose to fill this out if you like to meet someone on the team. But if not, that's totally chill. And I guess most importantly, the add deadline for this class, which is a 7-week class, is this Wednesday. So if you need to add this class onto the center and you want to take the class for credit, you have to do that by, I think it's Wednesday, 11:59. It's not it's 5
I believe it's 11:59.
Yep. So this is different from, standard Cornell classes. And also just as a reminder, I believe tonight is also the drop deadline for standard classes. So not this class, but this is just for your information. If you're planning to drop a class, tonight is the drop deadline, not for this class. I believe the drop deadline for this class is April 10th. So that's that. And if you do plan on dropping, please send us email so we can remove you from all the stuff so you don't get spammed from us. And yeah, let's get started with some content. So just as a quick recap, last week we covered mostly Swift basics, so lots of Swift syntax, for loops, while loops, and optionals, which are pretty important, and string interpolation, which I'm sure you guys, if you've done the assignment, you probably would have got to work with that a little bit. But this week, we're going to cover classes. So what is a class? So essentially, classes are what we call blueprints for an object. So I like to think of this as if you're building a house, right? So if you tell your architect to I want these standard properties for a house, and they give you back a blueprint. And essentially, each blueprint contains properties and functions that kind of determine its behavior and state. So in this case, each class essentially has properties to store different values, functions that kind of provide different types of, functionality, and also establish behavior and state. And I guess an important part of classes is that you must initialize all stored properties. So this means that if you want to define, let's say, a student class with a property that's net ID, you must provide a net ID for every object of that class that you create. And the distinction, I'm sure objects and class get used interchangeably a lot, but the distinction is that the class is the blueprint. So the class is the blueprint to the house, and the object is the house that you build from that blueprint. Does that kind of make sense? So you can build you can make multiple objects from the same class, i.e. you can build multiple houses using the same blueprint. Does that kind of make sense? So I guess a bit more specifically, we have a student class here. And we have a few properties, namely name, major, and age. So in this case, we use the student class, the student blueprint, to create a student object, namely Vin, with ID 1. And we see that we kind of initialize it with properties Vin, InfoSci, and 20 for each respective property. So the student object has information on the student's name, major, age, and basically when you come up with a class, you can determine, essentially pick yourself what properties you want to store in a class. So this is kind of to expand more on the point that for a singular blueprint, you can create multiple objects. So the blueprint was your class student that that's like, I guess, holds a name, major, and age. And the objects are these individual, I guess, students here that we create from that blueprint. So does that kind of make sense? Any questions? It's a little weird to, I guess, wrap your mind around the first time. But basically, so when you receive like a blueprint for a house, you can build multiple houses from that same blueprint. So I think Richie's going to demo now and show you guys how we can basically create a student class like this.
Yep, so we're going to open up another Xcode playground. So if you're here for lecture 1, we did sort of go over how to do that. But I'll sort of quickly walk through it again. So if you go open Xcode, so go to File, New, and then we'll create a new playground. And let's see, let's create a blank one. Let's call it L2, and we just save it to, save to desktop. Okay, perfect. Okay. While that's loading up. So yeah, I think usually anytime you sort of open Xcode, it's going to take a while the first time around. Like every single day, if you open it for the first time, it might take a few minutes to load. It might take a few seconds. It really depends. So, okay, so we're going to get rid of this. So as Tiffany explained before, we're going to be demoing the class. So what Tiffany explained before with the student class, we're going to create that right now. So how you define a class is you use the keyword class, and then after that, you want to specify the name of the class that you want to create. So in this case, we're going to use student. Okay, and once we do that, we can open bracket and sort of define anything we want, including properties, functions, initializer within these brackets. So let's say, we want to define all the properties before. So we have name, we have major, and we have age. So what we want to do essentially is create a variable. You can also use a constant, but in this case, we want to use a variable as well. So we want to be able to modify these later on. So you can do a var, we can call it name, and we want it to be of type string. So unlike normal variables, in this case, since it is a property, you have to, sorry, it's all too small. Is that better? Okay, perfect. So since it is a class rather than a class property, rather than a variable, you do need to have a type annotation. So each time you specify a property, you need to specify the name as well as the type. So that is mandatory. So we can also have a major, a string, and we can also have something like age. We can make that an int. Okay, so once that happens, you'll see once Xcode compiles, we sort of have an error here. It says class student has no initializers. So because we established properties in our class, we need to now create an initializer to initialize those properties. Because, we're sort of right now, they're only defined by their types. So we need to create an initializer that instantiates an instance of a student. So the student is the class, so that's the blueprint. But in order to create a student, like so for example, if we wanted to create a specific student, we'd have to instantiate it with the initializer. So how you can do that is just type init, and you can see Xcode is a very powerful compiler. So you can automatically just press enter, and it'll complete exactly for you there. So as you can see here, what this is essentially doing is this is defining a function called init. This is the initializer that takes in parameters name, major, and age. And it's sort of, what you see here is that it's assigning those parameters to the actual properties of the class itself. So you can see here there's this keyword self. So what this essentially means is that self is the object that you're trying to assign. So essentially it's assigning the property of this specific object, self, name, to the name that you specify in the initializer. So when you are calling the initializer, it'll directly pass in the arguments and parameters you get from the initializer function. It'll pass them and create an actual object of student and pass in those parameters into the properties. So you can demo that real quick right here. So we can do let G is equal to student. So this is how you call the constructor. A constructor should share the same name as your actual class. So you can see here, Xcode will also automatically finish that for you as well. You can enter it here. It'll sort of give you like the template code for how you can create a student class. So in this case, you want to specify the name, so Richie, major, UCS, and age, 20. Okay, so in addition to creating a student, we can also sort of access the properties that are existent in it. Since we do have var, since we do have name, major, and age, we can directly sort of access them through the variable we just defined. So let's do Richie.age. Okay, this may take a while to compile, but hopefully it does it pretty quickly. But essentially what I'm doing is I'm taking this new object I've created called Richie, which is an instance of the class student. and I'm trying to access the property called age. So hopefully this loads pretty soon. This is maybe going to take a while, but I'll skip if it doesn't. So essentially what this thing does is the same thing, and let's say I wanted to change my age, I want to increment it. So we could directly do the same thing and access it, except we can do richie.age is equal to, let's say, a new value. Let's say I turned 21. Then I can change the value. So that'll actually go into the student object, grab the age, and then change the age to 21. So I think this is just not running right now, but I think it's still launching. As usual, like Xcode takes a while the first time you boot it up, so it may take a while to run. It's just normal. It's like across all computers, it's going to take like a few minutes to run. But I guess, in the meantime, that's it for classes. So I'm going to pass it over to Tiffany to discuss a very important feature of classes, which is subclassing.
So I guess an idea with subclassing is that you're kind of creating like a children of the class, or I guess a child of the class, hence the word sub. So essentially what a subclass is that it's still a class, but the difference is that it inherits all properties and functions from the superclass. So you might be thinking like, why do we care? Like, why is that useful? And that's useful because let's say we wanted to create a variant of the student class. So for example, we have a bunch of students here, right? We have engineering students, we have arts and science students. So if we wanted to create a class called engineering student, we don't want to basically redefine all the properties that we already defined earlier. So we don't want to redefine a major, a net ID, like all students should have these properties. But let's say like for an engineering student, you might be curious, like how many credits are they taking? Or like, have they taken a shower yet? Or like, just like properties that might be specific to an engineering student, right? So essentially, subclassing allows us to have a class that basically inherits all these properties so that when you create a subclass and you define it as such, it gets inherited in the init function. So when you call super.init, after initializing its own properties, it basically, inherits all of those properties down from the superclass. So just to reiterate, the superclass is the student class, and the subclass is the engineering student class. Does that make sense? Any questions? Am I going too fast? Feel free to stop me. Cool. So I guess Richie will show you guys how that might look like.
So we're going to step back in. Okay, so there we go. You see, it's kind of run here, and you can see it's displaying the age here. It'll display student here because we're modifying, we're not actually accessing, so that's okay. Okay, so now what we're going to do is we're going to create, as Tiffany mentioned before, a subclass of student called engineering student. So again, we use this keyword, same keyword class again. This time we want to create an engineer student, and we want to make it a subclass. So how we do that is we use a colon, and we put the superclass. So the class that we want to make this the subclass of, we put that after the colon, and as before, we open the brackets to create a new class. So, like Tiffany mentioned before, one of the strengths of using classes is inheritance. So, rather than redefining name, major, and age, which should also apply to an engineering student, we can just sort of get that from the superclass. So, let's say we wanted to add a new property to the engineering student. So, as Tiffany mentioned before, let's create a new variable, and let's call it does shower. And let's make that a Boolean because that's a yes or no answer, meaning it can be true or false. So as before, we're also defining the type just because it's property. And again, it's saying there is no initializer, so the first step we're going to do is type init. And as you can see, it also does autocomplete as well, but you can see that it doesn't really autocomplete the remaining parameters that we need for a student. And you can also see that it has this error, super.init is not called. So instead of redefining all the properties like we did up here and copying and pasting this code, we can just simply add these to the parameters of the initializer. So let's say name is a string. We could do major is also a string, and age as well. Add those back. So we do need to specify those again in the initializer because when you're creating an engineering student, you also need to initialize those parameters. However, rather than setting them directly using self.dot, we can actually do what Tiffany mentioned earlier with super.init. And you can see that that autocompletes as well, and it will actually call this, utilize this initializer up here, and we can just pass in the parameters up here into this initializer, and it will also initialize these values for an engineering student. So in addition to properties and initializer, you can also include functions or methods in your classes. So we're going to define a function here. And let's say, since we want to modify the does shower, we can define a function. So using the func keyword, we can do take a shower. And then we can set showering to true. So this function will set does shower to true. Okay, so now that we have our class created, we have our property here, we have our initializer here, as well as a method. Let's try and demo that by creating a student. So let's create a student called Vin, and let that be an engineering student. So like before, we're sort of calling that constructor, and we're creating an engineering student like here. So the name is going to be Vin, major is going to be info and age, assuming it's going to be 20, and then we're going to put does shower as false. Not exposing anyone here. So once we do have that, you can see that, yep, we have our engineering student here like before. So we have a student, which is the superclass, and we have an engineering student, which is the subclass of student. So in this case, like before, we can also access its properties. So we can access the does shower property, and if we run it again, you'll see that hopefully this runs faster this time. You'll see it'll display false because we initialize it as false. So let's say we want to modify this as well. So because we sort of have this method that modifies it for us, we can have Vin take a shower. So Vin.take a shower. So that calls the method take a shower, and it'll perform whatever happens under here. And again, if we see take this code and print it underneath, we'll actually see that it'll modify it to true. So once he does call that function, it modifies whatever property that is modified within the function, and it'll actually modify that for the overall object that you're working on. So yeah, so as you can see here, does shower is only a property in engineering student. However, it is not a property in student. So you can see that engineering student can actually access the properties in student. So if we do name, it'll display the name like it was defined up here. However, if we take the previous student, Richie, and we try to access the shower, you can see that property is not defined in student. It is defined in engineering student, meaning that the superclass does not inherit anything from the subclass. However, the subclass inherits everything from the superclass. So essentially, you can think of it as like the parent class knows nothing about the subclass, but the subclass knows everything about the parent class. So this is sort of a strong tool to where you can save a lot of lines of code by using class inheritance to inherit properties from a superclass. Okay, so where does this tie into iOS development? So that's where we're going to go next with UIKit, which is the main topic of today. So I guess UIKit is the main framework that we're going to be using to develop iOS apps. And I don't know what a better way to give you an intro to UIKit than a quote from our favorite natural language processor, ChatGPT. So as ChatGPT says, a framework, UIKit is a framework for building GUIs and applications designed for Apple's various platforms. It provides a wide range of tools and components to create user interfaces for applications. So to reiterate what that means, essentially it is a framework that allows us to build the UI, the user interface. Okay, so what is UIKit? Again, UIKit is a library of classes. So as we mentioned before, each different UI type, so you can have labels, images, buttons, things like that. Each one of those views is a class in and of itself. So in order to use UIKit, you need to have some familiarity with how classes work. So it essentially provides a library of classes that represent different kinds of views. So if you want to create a label, we would use a UI label, which is the class name. A button, we would use a UI button, which is the specific name for a button class. And we can also modify these views and also modify its properties. So if you wanted to change the button color, change its text, change its font, things like that would also be properties within these UIKit classes. And why we want to do this is because properties determine its behavior and its state. So in order so when we modify the properties, we modify how that UI element behaves. Okay, so we're going to start with a quick demo here, and we're going to actually clone the repository. So there is actually a repository where we have all our demo content. So what you can actually do is if you go to the course website, you can follow along here by sort of downloading the demo code through GitHub. So what you can do is you can go to UIKit AutoLayout, and you see this link here that says clone the repository. You want to copy that. You want to go into your terminal, and you want to, let's say, change directory into the desktop so it's easier to see. And we can do git clone. So if you've done git with A1, you should be already familiar with this. If not, you can follow along like this, like so. So git clone, and then paste in that link from before, and you can see that it's cloning onto the desktop. And you'll see it's right here now. So if we do that, just close this real quick. And let's open up lecture 2 demo. Yeah, so I can give you guys a second to like do that, and I can move on later. So
Yeah, feel free to come up if you have any issues with cloning the repository. I believe, is there a zipped version of it or no?
I don't think this is zipped. It's all on. It should be all on GitHub. So
Okay. Oh, I see. Yeah. If you can't clone it, I guess for any reason, you could also just download it from GitHub. Does everyone know what that, like, how that looks? If you just download the zip file directly.
Or if like you aren't able to get it working by the end of the class today, you could rewatch the video and sort of take notes along when you get it working back at home. But I guess, does anyone else need more time to clone or anything? Okay, so I guess for the sake of time, we're going to get started with the demo. So as you can see here, once you open the actual Xcode project, so let me go back to the folder actually. So when you open the folder that you cloned, you want to open this blue file called with the sort of extension name .xcode project. That's sort of where you'll be modifying the code, and it'll open up the Xcode IDE here. So once you open this, you actually want to go, there's a bunch of files on the side as you can see. And let me just open that and make that a little bigger. Or not. Okay, so you want to actually navigate to View Controller. So right now for this lecture, we're not going to go into too much detail on what a view controller is, but that'll come up in actually, what's the question?
It says that the repository doesn't exist. Is that possible? Or I just want to know if that's like a local problem.
The repository doesn't exist.
But I couldn't get my lecture. Or
Is it because of your keys?
Do you guys configure the SSH keys?
Okay, wait, that's okay. Wait, so if you can't get it to work for this lecture, you can just, let's see, is this the link? You just,
Yeah, it should be the SSH.
are you able to just type this?
Does anyone else have the same issue with the existing? Okay.
Wait, so if you just click this link here instead of cloning, you just click code and download zip.
Yeah, you can just download
And then just
zip
unzip
there,
it for now, and then just come to us after lecture and we can figure out.
Yeah.
So the zip is the same files, so just like unzip and open the blue Xcode project file.
So there's another link. So above like the SSH copy, there's also a lecture demo link here.
when I click on that, it says like 404 is not the web page you're looking for.
Are you logged into? Okay, wait, Vin's coming. He'll help. I'm not really sure about.
You got it, Vin? Okay, all right. I guess just for the sake of time, we're going to continue with the lecture, and then if not, you can just take notes on notes or something like that. You don't really need too much of the actual IDE for this one. Okay, so what you can do once you have that opened is you can go to View Controller. So like I mentioned before, we don't really need to know too much about that at the moment, but in the next lecture, we'll sort of go over how the file structure works and what a view controller is. But for the time being, you can sort of think of it as the first screen that you see when you run the app. So right now you can see that it is a class called view controller, and it is a subclass of UI view controller. So it inherits a lot of the properties of that class. But since this is a subclass, we also want to define its new properties. So let's say we wanted a label on the screen. We define a property as before, so we can let label equals UI label. So this creates a object called a UI label, which is, you can think of it as sort of any text object that you would see on any screen. So that would be our UI label. So once we have that, we'll actually mark that, and we can call that our properties. So this is essentially how you comment on Swift. And this will sort of distinguish the code that this is where you're defining the properties, or in other words, the view. So we have our only view here, which is the UI label. And then what you want to do now, so now that we've created our label by instantiating an object of UI label, we want to actually set its properties and change some of the properties so we can sort of modify it to how we want it to look on our application. So what you can do here is inside view did load. So again, knowing what this function does is sort of outside of the scope of the course, but essentially this runs the moment the app first loads. So whenever this UI view controller loads, it runs this function to do a lot of the setup as well as processing that you do before the app runs. So what you want to do here is inside this function, we can set the label text. So you can set label.text. You can see that it has the attribute text, which is a string. And you want to set it as a string, so we can do my name here. And then other things you can do with the label is you can also set the font. So label.font is equal to, so there's another class. So for fonts, we can specify what font we want by using the UI font class, which is another class that can, sort of represents a font. So what we do here is we can use a system font, which is the default font that Apple uses. Again, wait, let me do that slower. So if you hit dot, you'll see system font, and then you can just click enter, and it'll autocomplete the first thing, as well as put in these code stubs there. And then let's do 24-point font. And then we can also specify the color here. So we can label .text color. And there's another class here for that. So like UI font, there's another class called UI color that represents the color. And we have a lot of options for the default color here. But just for simplicity's sake, we can go for black here. Oh, and another step that I forgot. So the UI view controller inherits a lot of the classes from its parent UI view controller, and one of which is a view attribute, which represents just the overall view of your first screen. So what we can do is actually modify attributes of this. So you can change the background color, and let's do it to something interesting rather than white. Let's make it, let's say, blue. And we'll change this to white, so it might be a little bit easier to see. And then once you're done with that, so just to reiterate what we've done here, we've created the view, which is the UI label, and then we've changed the background attribute, which is the attribute of our UI view controller, and we've also changed the attributes of our label. So this is our UI label, so we define it here and we set its attributes down here. So what we want to do now is actually run the application. So Xcode actually has its own iPhone simulator. So you can do is click this run button up here, or if you want a shortcut, you could do Command R. So that'll also run it as well. But this also may take a few seconds or minutes, so just wait tightly and hopefully it'll run. So you can see it's building and it says build succeeded. So if you have any errors, it actually won't build. So you have to fix any errors that are popping up in Xcode before you can actually run the simulator. So there's no build, some issue with build. It might be because if you click up here, you might have it configured for any iOS device, like up here. You actually want to select one of these simulators here because otherwise it doesn't really know what to run the application on. So if you have any build issues other than errors, make sure you go up here where it says iPhone 15 code right now and change that to any sort of iPhone you want. So as you can see, our application is running and somehow our label is still not there for some reason. So actually, one of the reasons why is because you see we have defined and created the actual view and we've set its properties. However, we're also missing a key component of UI development, and that is positioning the views or setting the constraints. So right now we've only created the view and set its properties. We don't really know where to place it yet. So another big, feature of UI development is setting constraints and positioning the views within the actual super view. So we're going to cover that, and Tiffany is going to introduce guys to AutoLayout. So let's do that.
Cool. And also, just so you guys are I know Richie types a little fast, but we do have demo code, basically all the completed version of demo code on GitHub as well. So don't feel pressured if you're not copying everything down. We'll have that all available for you guys to take a look at after lecture. Okay, cool. So we were experiencing the issue just now where we basically defined properties of this label. We gave it a name, we gave it its text, we gave it a font, but our label is missing, right? And Richie mentioned that important part of building UI is where does this label actually go, right? Should it be at the top of the screen? Should it be at the bottom of the screen? And that's essentially the problem that AutoLayout solves. So AutoLayout is essentially this looks like a lot of gibberish, but just know that it's a system that basically allows for screens of different sizes and orientations to, for you to be able to place these labels, these buttons, these texts on basically your iPhone screen, right? So more importantly, it uses a relational layout structure to organize views with respect to each other. So what that means is that we define where we want to place views based on where other views are located. Just let that sink in. So it's relational. So let's say if I defined I guess this might make more sense. So when we define this button or this label, hello world, there's a few different properties of it that we want to be able to establish when we're creating constraints for this label. Essentially, let me grab chalk real quick. So if we have, let's say, this is our phone screen, and let's say this is like, the Apple Notch. And we're making this label called hello world. Can anyone see this, by the way? Okay, I will try to duck. But let's say we're making this label, right? So it's hello. And let's say we want the label to go right here. So there's a few different properties we notice. There's this, what we call the leading. So if you look here, it's called left anchor here, but we also refer it to as leading, which is like, I guess, the front of the label. So this is your leading anchor. You have to define how much distance is between your label and the start of your screen. Your trailing, which is how much distance is between the end of your label and the end of the screen. Does that kind of make sense? But then, let's say you define these two properties, but the label could also technically be here, right? Because we have the same trailing, the same leading. So on top of that, we also have to define a top and a bottom anchor. So that tells the label, oh, how far should I be from the top of the screen and how far should I be from the bottom of the screen? Does that kind of make sense? So let's say, labels are too boring and we want to add a picture. So let's have a smiley face. And let's say we define this label already. And because I mentioned that AutoLayout is relational, the way we define this picture will be relative to the way we define this label. So what I mean by that is, so for this photo, we can also use this leading and also this trailing. And what happens here is that instead of defining this photo to the top of the entire screen, what might make more sense is if you just define it relatively to the bottom of the button. Does that kind of make sense? And then you can also give it a bottom anchor here. Yeah? Okay. And then also alternatively, you can also define it using a height and a width anchor. So you can basically tell it, oh, like how tall is this and how long is it? Yeah. So that's that. Let me get back here. And the UIKit, what we basically use to create these constraints is, it's called AutoLayout, but I believe we can just go straight to the demo. So what's going on here is that, let me get back to this. So our view isn't showing, right? And we basically, I mentioned earlier, we need to basically constrain this label so that Swift knows where to put this label on the screen. And how that essentially looks is, I guess we just do it here. It's called NSLayout. So if you type this, it will kind of, autofill itself. And you call .activate. So Swift is really nice. You can autofill code like this. And then you click enter again. And it's essentially like a list in here. So I'll pause here for a second. And this inside of these brackets is where we want to define our, I guess, constraints for this label. Is everyone on the same page? Cool. Feel free to stop me or slow me down if you're confused about anything. Okay, so I guess let's do that. So we have this label object. So we want to define, let's say in this case, let's give it a top anchor. So you call label.top anchor. So that's, you're defining this right now, right? You want to tell it how far should it be from the top of the screen. So let's say constraints equal to, so you want to call view dot safe area layout guide. So that essentially is like the top of the screen. It's called safe because it won't clash with like the notch or like when there used to be like a home button or like when there used to be like anything that might disturb the screen. This property essentially refers to like the top of this. Yeah, I'm walking around a lot. So we can call its top anchor. So that refers to the top of it. So we're saying, okay, we want to constrain the top of this label to the top of the screen. Yeah? Okay, so after we define this, we also have to tell it where we want it to be in the x direction. We told it, okay, we want it to be basically up here, but where do we want to be in terms of like, should it be on the left side? Should it be on the right side? Should it be on the center? So let's make it in the center for now. So we can do label.center x anchor. Anchor dot constraint equal to view dot. So there's a center x anchor property here that essentially just allows you to constrain it to the middle of the screen. So you don't have to do any sort of like calculation to figure out where you want that to be. Yeah. So we have this, but before we can run this and have it like actually show up, there's an important property of this label that we have to set, which is its, let me give it some space here. Name, not name, label dot translate. So I won't type all that, but it's translate auto-resizing mass into constraints. And what that essentially means is that you're telling Swift basically that I want to be the one to constrain this label, so don't constrain it for me. So if you don't set this property, your label will not show up, and you'll be sad, and it'll be like you'll be debugging, and this is like one of the first things I check. So it's this, and also you have to make sure that you add this label to this. So this view refers to this view controller, and you want to add this label to this view controller's view so that it appears. Does that make sense? Okay, let me run this and see if it appears. Simulator. There you go. So as you can see, Richie's son does indeed appear. And notice that we did set the background color to blue. So the background color of this view is currently blue. Any questions? Okay, cool. So now I'm going to kind of go over how we can create and display an image. I think that's a pretty common thing that you do want you to show in apps. So firstly, I do want to show you guys this really cool thing called Git checkout. So if you go over to, let me go back here. We do have two branches for this repository. So does everyone know what branches are by chance? I'll cover it really quickly. Essentially, you have your main branch, which is just like, where the bulk of the repository is located. And then certain branches allow you to access different parts of a feature. So this first branch is called UI label. So if you missed any of the code just now, you can just git checkout 1-UI label, and your Xcode will load in all that code we just typed. And then what I'm about to cover is UI image view. So you can just git checkout 2-UI image view, and that will load all the code that I'm about to type. Yeah, okay. So let's get back to this. So for this one, I'm going to organize this a little more and use functions instead. So to define, firstly, this image view object, you can just define let profile image view equals UI image view. So essentially, we're creating an object of this UI image view class, right? So then let's set up this image view. We can write a function in this case, since this code is like, once we create more and more views for a certain class, let's say you make a bunch of text, a bunch of buttons, a bunch of labels, you can imagine like if we just stuff all the setup for every single one of those things in this function, it's going to get really ugly and really messy really fast. So in this case, I'm going to showcase kind of how we can create a function to do this for us. So I'm defining this function called setup profile image view. So let's see. So if you take a look in assets, there's already an image here. Oh. Huh? I thought it should be an image. Oh, did you pull label?
You're not, you have to check out the other branch.
Oh, you're right. Frick, okay. Live action, give checkout, UI.
Oh, your desktop with the CPU too.
Oh, also, if you don't want to retype commands, if you just hit the up arrow, it like cycles through your most recent commands. Oh, sorry, get slash. Okay, so now I'm in this new branch. Okay, so essentially, if we take a look here, this is essentially the same thing that we did earlier. So this is like within a function, and essentially what we did is that we called this function. Wait, this is everything set up. Okay, let me get rid of this. Sorry, pretend this should not have been set up already. I'll keep this. Okay, so this should be where we were before, right? We have this name label when we call this function, which basically runs all this code that we defined earlier. And now we're working with this profile image view, right? So to set this profile image view up, the most important part of an image view is obviously the image, right? So we have to tell it what image do you want to showcase. So in this case, you can simply do profile image view dot image, which is the image property of this view, and set it to this UI image. If you just go down, there's a filler called named, and you can simply put the name of the asset. So in this case, there is a asset here of Vin eating a cookie, I believe, and you just fill in the string name of whatever you call the asset. Does that make sense? So you set this property, and we also have to add it as a subview, right? So we have this image, it knows what to display. We have to add it as a subview. Add subview. So essentially, this is like the same for every a view that you define, I guess. So whether it's a label, a button, a image in this case. And then we also have to, basically do the same thing that we did here, right? We also have to, since we want to basically constrain this image ourselves, we want to tell Swift, okay, we don't want you to auto-constrain it for us, so we just do dot translate. I never actually typed this. If you just type translate and hit enter, it does that whole thing for you. And then, so I set the image, I added the view, I set this to false. Can someone tell me what I should be doing next to get this image to show? Not a trick question, I think. Okay, well, I guess it's over there, but we have to basically tell Swift, like, where should I put this image on the screen, right? It knows what the image is, but, like, you know, where do we actually want it to appear? So in this case, basically, we do the same thing as before. You call NSLayout constraint, and you call activate again. Open the brackets, and we're going to try, so before I did a top anchor and a center X, in this case, we're going to go through the whole process of setting, if you wanted to use top, I guess, leading, trailing, and bottom anchor. So we're going to go through all of that for this image. So let's go. So profile, image view, dot top anchor. I'm going to speed a little bit just because I think we're a little low on time. So in this case, do you guys remember how before I mentioned you can constrain views relative to one another? So we already have this label set up, right? So we want this image to appear, you know, generally under the label, which I guess that's not really, I don't know, design convention. But you can essentially call this labels bottom anchor. So essentially we're saying we want to make this image appear under the label we defined earlier. So bottom anchor, and we give it like some padding, what's constant, and we just pass in 20. And then we have this top anchor. We also should define a center X anchor constraint equal to view.centerX. So that basically puts it in the center of the screen again, like the label. And then we can also define a height anchor, which basically tells Swift how tall should this image appear. So constraint, oh gosh. So in this case, we wanted to set it to a constant, right? We don't actually want to constrain the height of an image relative to something else, so we can just pass in an actual pixel value. So in this case, we're passing in 256, and then if you pass in the height, I guess you generally also want to pass in the width, right? So you also just constrain this to 256 for it to be a square. Does that make sense? So that's kind of a lot, but all this code will be up there for you to take a look at after, and also feel free to just post on Ed, come to office hours and ask us questions if you have issues with anything. And then so we set this function up, and the last part is to just basically call this function as well, right? So we have this setup profile function that basically runs all of this. but it won't actually work if we don't call it in our view to load. So let's run this, and hopefully an image will pop up. Any questions? Okay. Boom, boom, boom. Gosh. Okay. A little jump scare, but that's okay. So as you can see, this is like about 20 pixels, but we basically constrained the top of this image to the bottom of this label, right? So essentially, that's how like a lot of your view positioning is gonna go in this class, and I think that's it for the demo. So I'm gonna.
Okay, I guess like before we move on
yeah.
to like the Kahoot, I think the repository is working now, so I'm going to re-demo how you can sort of get access to this lecture demo code. So again, go back into the textbook here, copy this SSH, and you can sort of go, let's go to desktop again. So whatever repository you want to go into, you can use cd, which is change directory into that directory name. In this case, it's the desktop. And you want to type in git clone and then paste in. And okay, so it should exist. Let me just delete that real quick. So it says that repository exists, but now if you clone, now it's cloning again, and it'll show up here. So since this is actually the empty repository, so this actually has none of the demo code on it. But if you are falling behind a lecture or you happen to miss a lecture, you can still gain access to the completed demo code by checking out the UI image view branch. So what we can do here is copy out this. So copy this specific checkout. So this, usually the second one is the completed demo code. So you can go back here. You want to cd into the lecture folder, so lec2-UIKit. And you can do paste that in. And if you do that, now you'll be switched to the completed branch and you'll actually have full access to the lecture code. So close it. And then if you open that, instead of having the template code, it should actually open up with the completed demo code that we had from lecture today. So yep, so this has all the completed code. So if you did miss anything from lecture today, you can follow those steps and actually get access to the completed demo code. Okay, so I guess we can move on to the Kahoot. Just stop recording.